Good evening. I welcome you all for the today's session, implementation of Boolean expression using universal gates. So in our lecture series, in the previous session, we discussed about all logic gates. Continued with that, by using that logic gates, at the end we discussed about universal gates. Now we are going to implement the Boolean expressions using universal gates. Okay. So same as AND gate, OR gate, all those gates in our logic gates, everything is already we have studied in the previous class. Now we are going to see how they are used to implement by like NAND and NOR implementation. Means using this XOR and XNOR gate, we are going to implement NAND and NOR implementation. So a Boolean function can be created using any gate, design like basic gates, by using basic gates and or not. So what are all the basic gates here? And or not. Okay. So these three are the basic gates. By using these gates, we can design what else implementation to be done. It is possible. So the additional inverters in the input, we can achieve an OR gate. Like we are using De Morgan's theorem here. We have studied about principle of duality theorem and De Morgan's theorem. So the OR gate can be implemented by using NAND gate. See, a simple OR gate. The equivalent of this OR gate for NAND implementation is the right side circuit, which is given like we are using NAND gates. We are using NAND gates and inverters. We are using NAND gates so that the equivalent of OR gate is said to be as NAND implementation of OR. So how we have certain equivalents for each gates, equivalent symbols of each gate. For NAND, we can replace an OR gate with inverters at the input so that the same output will be received in both the gates. So what is the output received in NAND gate? X, Y, Z bar. The same answer will be received when you when you connect inverters at the input of an OR gate. We will get the same answer. So this is the equivalent gate of NAND gate. Okay, it is shown here. Likewise, each gate has its equivalent representation. So the representation of Boolean function, we have certain levels to implement a NAND gate. So here we have two-level implementation of NAND gate. So the representation of Boolean function with NAND gate requires and simplified into sum of product term. So this is the function which is given here, like AB plus CD plus E is the function. That is our Boolean expression, right? So how we can differentiate to the next level. So we need three NAND gates for each variable like A, B, C, D and E, and one NAND gate to represent the function, that is our output. Okay, so the second circuit is the equivalent circuit. So now we need all the gates completely as NAND gate. So instead of that, we can use the equivalent gates as given in the circuit. Like for NAND, we can use NOR gate with inverters at your bubbles. Okay, inverters with inverted bubbles at your inputs. So the NOR implementation of NOT and AND using NOR gate. So here the De Morgan's theorem, putting two extra inverters in input, the NAND gate is replaced by NOR gate. So here you can see the AND gate. The NOR implementation of AND gate is, we are using NOR gates connected together, two NOR gate given to a NOR gate. So instead of all the AND gates, we are replacing NOR gate. So this AND gate output is received same in this equivalent NOR implementation of AND gate. So likewise we can give, that is your NOR gates. We are using NOR gates. If it is double time inverted, we will get the same answer. Okay. So the NOR implementation of OR gate using NOR gate is, In the previous slide we used AND gate. So instead of AND gate we are using OR gate, and this is the representation of NOR implementation of OR gate. Okay, so the graphical equivalence of NOR gate, as we have seen for the AND gate, here we are seeing the graphical equivalence of NOR gate. So NAND gate can be given equivalent as when it is given the input, when the input is given with inverters, we receive the same output voltage received in our NAND gate. Okay, so the NOR implementation of OR gate using NOR gate. So this is the equivalent circuit of OR gate while we implement NOR implementation of OR gate. So these are all the implementation of NAND and NOR using logic gates. Thank you. This is the graphical equivalence. Thank you.